So today we will be finishing the remainder of 5.1 that we had not finished in last Wednesday. So these are just what you've already written down or should have written down last week, and if not, they're in your book in 5.1. So just as a reminder, we have reciprocal identities, which we're pretty familiar with at this point. We've used those for a long time without necessarily writing them down to specifically be identities. The quotient identity is probably the biggest thing out of those just basic ones. That tangent of theta is sine of theta over cosine of theta, and cotangent of theta is cosine of theta over sine of theta. The big ones that we'll be using today with the remainder of the stuff we have, in combination back with these reciprocal identities that we had, are these Pythagorean identities. So remember, we worked through how to actually find these if you just know this first one, that you can just divide it by sine of theta or sine squared of theta or cosine squared of theta to get the remainder of them. Okay, but just keep these fresh in your memory and close by as you're doing the work and stuff, because it will be important with this particular lesson, and I'll try to remind you of them as we go through some problems. We have the cofunction identities, which we really won't use today. We won't use those a whole lot. It's just good to have them on hand. I know we used them some the other day, but out of today's stuff, we won't really use them. And then lastly, the other identities that we had were these odd and even identities. That was just if you have like the sign of a negative value, then it's negative sign of that value. Cosine of a negative value is positive cosine of x, so keep in mind that's dealing with whether or not it's an even or odd function. And we talked about those last week as well. So just to get this fresh in your memory, in your notes, whatever. But we got through, I think it was problem 32 right before we had this break. So we're going to start with 34 today and go from there. But basically with these ones, it says to combine the fractions and simplify to a multiple of a power of basic trigonometric functions. Okay, so we are going to be kind of going back to some of the stuff that you've done just all throughout math in the past with these fractions here. So 34 is 1 over 1 minus sine of x plus 1 over 1 plus the sine of x. Okay, that's the problem statement that we are given. So we need to get a common denominator, and then we can add the stuff together and combine everything down. So these look almost the same, okay, but we do have a negative in this one and a positive in this one. Okay, so we need to multiply this one over here by 1 plus the sine of x over 1 plus the sine of x, and we're going to do this one by 1 minus the sine of x over 1 minus the sine of x. So I'm going to go ahead and actually write that step out for you. You would not have to do that if you were just doing them on your own, but just to make sure we understand what's going on here, I'm going to write out even more steps than I normally would. Alright, so I now have that step written out for us there, and so I can just go through and multiply the top, and I can go ahead and just write it all as one fraction, so that's what I'm going to do here. So 1 times this step on the top is just 1 plus sine of x, plus, that's just going to be 1 minus the sine of x, all over. Now the bottom we're going to actually multiply, so I'm going to do this in 2 separate steps just so we can see what's going on here. So this is going to be 1 minus the sine of x times 1 plus the sine of x. So now with these, the bottom, okay, hopefully you recognize this is a difference of squares, okay, and can be written as 1 minus sine squared of x. So I'm going to go ahead and write my fraction again. So 1 minus sine squared of x. And up here, we have 2 1s that are positive, but I have a positive sine of x and a negative sine of x. so I can get rid of those two, and I'm just left with a 2 on the top. And then going back to our identities, okay, we have the identity that says that the cosine squared of x plus the sine squared of x is equal to 1. So we can do 1 minus sine squared of x is equal to cosine squared of x, meaning that I can rewrite this over here as cosine squared of x, so that gives me 2 over the cosine squared of x, which is equal to, we remember that cosine goes with secant, so that we can rewrite that as 2 secant squared of x. And that would be our answer. I'm going to focus this in a little bit. It looks like it might be a tiny bit blurry. See if we can clear that up some. It's been being a little weird. Alright, so that one's kind of one of the easier ones, in my opinion, but 38 is going to be our next one. Still not hard, but because it follows the same pattern, but it is a little different in how we do it. So 38 is next. So this is going to be sine of x over 1 minus the cosine of x plus 1 minus the cosine of x all over the sine of x. So if you notice, these are just reciprocals of each other, okay, but I still have to get a common denominator to actually add them together. So this one over here is going to be multiplied by sine of x over sine of x. This one over here is going to be multiplied by 1 minus cosine of x over 1 minus cosine of x. So again, I will go ahead and write out that step for you so you can see it. Alright, so over here, on top, I'm going to go ahead and just write it as one fraction just to save some time, is going to be sine squared of x. Now, the most common mistake that's probably made right here, this is not a difference of squares. Okay, notice the signs in these are both negative, so I have to think back to what this actually is. Okay, so this is going to be 1 minus, so what we have here is minus cosine of theta minus another cosine of theta, so that's going to be minus 2 cosine theta, or 2 cosine x, sorry, I say them back and forth all the time. And then lastly we have the minus cosine of x times minus cosine of x, which is plus cosine squared of x. Okay? And this is all over this stuff on the bottom. I'm just going to leave it separated out into 1 minus the cosine of x and sine of x. Look at that again and see if it'll come clear. There we go. That's much better. Alright, so then up here, okay, cosine squared and sine squared. Okay, well we know from our identity that I wrote up here, so I'm not going to write it again, that that's 1. So I can replace those things with 1. So I have 1 plus 1 minus 2 cosine of x. Okay, and this 1 minus 2 cosine of x is from right here. Okay, all over 1 minus cosine of x times the sine of x. So this is really 2 here, so I'm just going to cross this out and make that a 2 just to save me a step. So now what I can do is I can pull out a 2, because there's a 2 in both parts of the top. So 2 times 1 minus the cosine of x. Well, that's good because I have a 1 minus cosine of x on the bottom, over 1 minus the cosine of x times the sine of x. Well, the 1 minus cosine cancels top and bottom, leaving me with 2 over the sine of x, which is, we know sine of x goes with cosecant, so it's going to give me 2 cosecant of x as my answer for that one. Alright, so that's that type. So the next thing, the next section of problems that we have is 39 through 46, but without actually being in class and being able to work through them, I would rather just kind of skip some of those. The only one you're going to be responsible for is 39 and 40, so I'm going to work through 40, and then you guys will have to do 39. Let me take this one away, and we'll go ahead and jump in with 40. Okay, so for these ones, it says to write each expression in factored form as an algebraic expression of a single trigonometric function. Okay, so basically it wants us to factor it, so it's going to have two things in parentheses, or possibly one thing being squared. Okay, so I have the problem statement says 1 minus 2 sine of x plus sine squared of x. Okay, so you're probably looking at that, and maybe you see right away how to factor that, but maybe you don't. So the way I like to think about it is I like to use substitution. Okay, so I use substitution. That marker is awful. This one. So we're going to use substitution. Okay, so we are going to say let sine of x be equal to x, okay, for the time being. So whenever we get back to the end, whatever x ends up being, we're going to replace that with sine of x. Okay, so we end up with then 1 minus 2, remember sine of x is x, plus, now we have x squared. Okay, and because when I'm doing factoring, I like to write it in the other form or the other direction, I'm going to rewrite it as x squared minus 2x plus 1, just to make my life a little easier. So maybe you notice at this point that this is a perfect square trinomial. Maybe you don't. Okay, so if you don't, remember the way we can think about this. Okay, obviously you got the arch method and all of that. So this ends up factoring into x minus 1 times x minus 1. Okay, or x minus 1 squared is the official simplified all the way down form. Okay, but now I need to go back and I need to replace x with sine of x, okay, from up here. So I need to come back in and substitute it back in. So I'm going to do that now. So that's going to give me sine of x minus 1 squared, which is my final answer here. Alright, and 39 is pretty much the exact same way, it's just using cosine. So it shouldn't be anything too difficult. Alright, so the next thing we're going to look at, we have two more little things we're going to look at here with this section. So 48 and 50, we're going to do both of those. So these ones say to write an expression as an algebraic expression of a single trigonometric function. So basically we want it to be one thing that would normally be like in parentheses kind of thing. So 48, we have that and they use a little like alpha. You can just write a or whatever variable you feel like, but they have the tangent squared, or some of you will like to call it fish, minus 1 over 1 plus tangent of alpha, fish, whatever. Alright, so when you're looking at these, okay, you have to figure out, can I rewrite something that I already have? So the top of this up here reminds me of a Pythagorean identity, so I need to think back to my identities page. And the one that comes to mind is 1 plus tangent squared of theta is equal to secant squared of theta. Okay? Now, I have to think about this and see exactly how I need to rewrite this. Okay? And if this is going to work. Okay, does this identity work here? Well, I have tangent squared minus 1, and this one is tangent squared plus 1. So maybe that's not going to work for this one. So the identities don't work on here. The identity is not going to work for that one. Okay? But maybe I also noticed that this is a difference of squares. So maybe we can try that and see if that will help us. So we could do tangent of alpha minus 1 times the tangent of alpha plus 1. That seems like that might help us. Over 1 plus the tangent of alpha. So this top part can cancel out with the bottom part. Okay, even though they're in a different order, they're both being added. Okay, they're both positive, so we can cancel them out, leaving us with tangent of alpha minus 1 as our answer for that one. Get that out of the way here. So then 50 we have tangent squared of x over secant of x plus 1. Okay, so now maybe the identities will help me. Let's just see here if they will or not. Okay, so I have the same identity up here to think about. Okay, 1 plus tangent squared of theta is equal to secant squared of theta. Okay, well, I have a secant plus 1 on the bottom, but that's not squared, so I can't really do anything there. But maybe I could rewrite tangent squared. So let's look at that. So tangent squared of theta would be secant squared of theta minus 1. Well, now, based on what we did up here with the tangent squared, this also is a difference of squares. So I can take that and replace that and use the difference of squares. So this becomes secant squared of x minus 1 over secant of x plus 1. Now that difference of squares on top becomes secant of x plus 1 times secant of x minus 1 all over secant of x plus 1. Now these two cancel, leaving me with secant of x minus 1. So that's that type. So those ones are just learning and replacing stuff. So that should help you in terms of doing your identities and helping you to learn your identities, because you have to actually go through and use them a lot. So the last thing we're going to do, pretty simple. I probably don't even really need to show you 2 examples, but I am, just to make sure you have enough to go off of since we're not in the classroom actually doing these. So we're going to jump to the stuff that's like 69 through 74, okay, and we're just going to do 2 of them. So with these ones, it says make the suggested trigonometric substitution and then use the Pythagorean identities to write the resulting function as a multiple of a basic trigonometric function. Okay, and I'm going to go ahead and tell you we're taking the square roots of things, and the square roots must be positive, so our answers have to be written in absolute value bars. Okay, so because we're taking the square root of trig functions, okay, they must be positive, so they need to be written in absolute value bars. Alright, so with this one, okay, we're going to start with 70. Start something simple. Is the square root of x squared plus 1, and we're told that x is equal to tangent of theta. Okay, so I'm going to replace x with tangent of theta. So I get tangent squared of theta plus 1. Well, we just saw from our identities, okay, that is equal to secant squared of theta. So that's equal to the square root of secant squared of theta, which then is going to be the absolute value of secant of theta. Okay, and that there is the answer. Okay, so that one was pretty simple. Let's look at one that takes slightly more steps, but only by like 1 or 2. So 72 is the square root of 36 minus x squared, and we're told that x is equal to 6 sine of theta. So I'm going to replace x with 6 sine of theta. So square root of 36 minus, now this is in parentheses, 6 sine of theta, and all of that is squared. Okay? So I'm going to go ahead and square everything here. So this is the square root of 36 minus 36 sine squared of theta. Okay, so I'm going to go ahead and pull this 36 out. So it's going to be the square root of 36 times 1 minus sine squared of theta. Okay, and because this is being multiplied, we could, if we wanted to, rewrite this as the square root of 36 times the square root of 1 minus sine squared of theta. Okay, so that's an option if you want to, but I just left it in here when I was doing them earlier, so I would recommend just leaving it in there. I just think it makes it a little simpler and less moving parts. So this becomes the square root of 36 times, now 1 minus the sine squared of theta is, according to our identities, is cosine squared of theta. Okay, so now I can take the square root of those two things, okay, which means that this 36 is going to become 6. Okay, now the part where it might get confusing, okay, the only part that's in absolute values is these trig functions. So now we're going to do the absolute value bar, cosine of theta, and that would be your answer. So 6 absolute values cosine of theta. Alright, and if you have any questions, I put that Google phone number on my paper I sent out to you, so you can look at it there. Your homework for these sections, see where I wrote it down for you, is going to be 33, 35, 37, 39, 47, 49, 69, 71, and 73. Okay? And those are due Sunday night by midnight. Okay, to my email. And if you could, to help me out, in the subject line, put your name and the class so that I know exactly what it's for. And you can submit this with the 5.2 homework as well.